In order for a reaction to actually take place, it needs to be balanced. So basically what that means is that each element there has to be an equal amount of each element on each side. So or in the reaction total. So basically, to balance this synthesis equation, since there are two O's here, you have to add a 2 to this blank over here. And now, since there are two Mgs, magnesiums, over here, you have to add a 2 over here, and then that is balanced. So basically, for double replacement, we're just going to do the same, and this last reactant is supposed to say Ba times NO3 and then to the second, but I ran out of room. So basically, to balance this one, since there are two NO3s on the right and there's only one on the left, we have to add a 2 to the left. And then now, since on the left there are two Ags, you have to add a 2 here. And since there are two Cls, the 2 in front of the AgCl also balances that Cl out. So combustion reactions can be a little more difficult to balance, so I have a really easy trick. So basically, you're gonna put a 1 in front of the carbon, and if the 1 doesn't work, you'd put a 2, and then you'd balance the carbon, then the hydrogen, and the oxygen last, and if the 1 originally doesn't work, then you just repeat and keep getting higher. So here, since so this side you'd put a 2 because I just know that 1 would be too small to balance this out. And then on this side, since we have 14, on the left we have 14 C's, so you have to add 14 to over here to make to the right side, to make the right side have 14 C's as well. And then now you have 28 O2s, so you're going to add a 17 to the O2, and then you're going to add a 12 to the H2O to finish balancing that out. Now we're going to balance a single replacement reaction. So you can see that on this side there's one Na, and this side there's also one Na, so we're good. And this, by the way, HOH is also H2O. So basically, if you rewrite that as H2O, sometimes you can see it a little better. So we have two H's on this side, and we have one H over here. So over here, you can add the little 2, and then, or not over there, sorry. Over here, you're going to add the 2. And then you're also going to have to add the 2 in front of the Na because the Na is now imbalanced. And then you also need a 2 over here now because the OH is imbalanced, and that is how you balance a single replacement. So you can clearly see this is an acid base because there is an H in front of the Cl, which makes it an acid. So over onto the right side, you have two H's, so you have to add a 2 to the left. And then now you have two Cl's, so you have to add a 2 to the NaCl over here. Now you have two Na's on the right, so you have to add a 2 to the left. And then if you rewrite the H2O as HOH, you see that it is all balanced. The last reaction we can balance is this decomposition problem. So to make it easier, I'm just going to write this as HOH, just for reference. And so you can clearly see that there are two O's on the right and only one on the left, so you have to add a 2 there. And then now there are 4 H's on the left and only 2 on the right, so you add a 2 there, and that is completely balanced.